LED light sources have unique spatial characteristics which usually lead to higher luminance and a smaller luminous area of the lamp. And I've talked a lot about the theoretical background behind this in earlier videos. In this one I'd just like to show you how it looks like in real life. Starting with an LED floodlight, we have a reflector around what seems to be one big LED chip. And when it's on, we see that, of course, for the naked eye, this whole area would look like one big blob of glare, but with this filtered image, we see clearly that very little light is coming from the reflector around the LED, so it's kind of useless, and most of the light is coming directly from this LED chip. And when we look closer, we see a bug, but we also see that in this image, this whole area looks like homogeneous and saturated completely. But we also see that there's a great difference in luminance between the area of the LED chip itself and the area next to it, which is much darker, where the reflector is. And there's a clear, sharp, high contrast transition between the two. However, when we look even closer, it turns out that this LED chip is not a homogeneous unified thing. It is unified as one light source, but it actually consists of many LED diodes, and at these diodes the luminance is much larger than next to it. Now, comparing this to its halogen counterpart, a similarly sized halogen floodlight. Of course, in this video I'm not comparing absolute flux of these light sources, I don't even know that, and also absolute values of luminance we cannot compare this way. It's just to illustrate the general pattern of how the light looks like from these usual light sources, which then, of course, all else being equal, is going to affect luminance. So this is how it looks like with the halogen light. We see a larger luminous area, and that a larger part of the total luminous area is utilized, and that is the case from different angles. And in this image you see a little better the filament itself, which is the brightest part, but much of the equally bright or nearly equally bright light is projected from the reflector behind it, and the transition between darker and brighter areas is more gradual. Moving on to a car headlamp. This is a Lexus CT from 2021 with a pretty average LED projector headlight, so it could be on any other car. And when you look at it from different angles, usually just a small area is bright, but when the viewpoint is from the center of the beam pattern where it's brightest, here in this image we see a T shape which is completely saturated, so we don't see how the luminance is distributed within this area. I'm going to show you in a second. But from most other angles there's just a smaller but very bright part of the total area which is luminous, and the rest is basically dark, so it's as bright as its surroundings, whether you look at it from within the beam pattern or from outside of it. And here again is this brightest part of the beam pattern where I took this image from, and I used a DIN 10 welding filter for it. And also for the naked eye, funny enough, this filter didn't seem enough, so it was still pretty bright, which is ironic because you can weld with it, but it's not enough for LED lamps which are everywhere on the roads. But so there are indications also in this image that although the image is saturated for a larger area, the luminance might not be equally distributed. We see from these lines here a little better. But so if I take two layers of the filter, it becomes very apparent that we see the shape, somewhat distorted shape, but still a projection of the shape of the LED chip, which is very bright, and around it we find much lower luminance. Again, back to an image with just one layer of filter, we see a little bit of this shape of the LED chip again. And we also see some color separation, which could be better illustrated with a neutral density filter, which I didn't have for this image. And also the welding filter is the reason for this green color. It's not relevant for this demo. But from most other angles, it's clear that there's a bright little spot and most of the rest of the surface is not luminous or less luminous. There are several spots in this case. And that is true also when you are outside of the beam pattern, and even more so in this image, which I took from above and very much from the side, and yet, so there is basically no meaningful illumination at the location of the viewer in this image as well. Nevertheless, there's a very bright and very small spot of light in the center of the projector lens, and that is why LED headlights are usually glaring also when you look at it directly from the side. So until the car passes, you do get some glare because of this high luminance, even though there is no significant illumination at the position where you are. Comparing this to halogen, here I have a circular one. I tried to find one for better comparison. This is a Mark II Golf from the 80s with an H4 halogen bulb. And when you look at it from the front, again from the brightest part of the beam pattern, more or less, we see a dark shadow in the center of the cover lens, and that is created by the cap of the light bulb, so direct view of the filament is prevented by this. So all the light that we see is reflected from the reflector behind the light bulb. And we also see that most of the area is utilized of the otherwise also much larger cover lens, of course, of this reflector lamp. The cover lens is about 3 times as large in diameter than that of the LED projector lamp that we saw before. And this is the same with the high beam on. And when you look at it from a larger angle, so you're again outside of the beam pattern, there's very little illumination at this position. Also, it's not so bright. I didn't need a filter at all. But we see that pretty much the whole area of the cover lens is luminous, not so homogeneously. There are brighter and less bright parts, but the transition is smoother and most of the area is utilized so that brightness is much lower. And that is also generally true for these halogen lamp types. While with the LEDs, we see that there's a sharp contrast between the darker parts of the luminous surface and the brighter parts, the LED chip in this case. And furthermore, if we take a higher resolution image, we see that even within this, in the image saturated region, there are large differences in luminance where the LED, where the diode itself is, relative to the surrounding areas, similarly with the car headlight. And that's why it would be important with these LED lamps not to average the luminance across the luminous surface, because that results in a very different value as opposed to when the peak luminance is taken. And then there's a further question to what resolution to use for that and how to measure that exactly. I'll include some links to further readings and the earlier videos about the theory as for why that is the case and why this is a problem with LEDs. And otherwise, that was it. Thank you for watching.